Okay, so we'll talk now about genetic resource evaluation and also new cultivar breeding. It's a presentation that we did together with Mark, so Mark, don't hesitate if you have comment or if you want to give advice on some slides. So we'll talk about the context and principle and objectives of the CRAW or Institute in Organic Palm Fruit Breeding. We'll also talk about disease tolerance and quantitative traits using landrace as parent. And finally, we'll go through principle of palm fruit breeding that probably most of you already know, but it's sometimes good to have a refresh. And it's also focusing on the way we are doing the breeding, but it doesn't mean that it's the only way, and maybe some other institutes are doing differently. So just it's nice that Ludo said in the question, the last question with Mark, that the biodiversity was reduced, and it gave a nice introduction to my talk, because indeed there is too many organically cultivated apple that are highly susceptible to disease, or at least too susceptible to diseases. And they are in fact not really adapted to organic production. And so it leads to the use of too many fungicides spraying. And here's just a graph showing example of some cultivar. You probably know here the Topaz, Gala, or Golden Delicious, that show quite high susceptibility to apple scab, both on leaf and fruits, and also powder mildew. This is just another example of the evaluation that we do in our orchards. And you can see, for example, here is also for apple scab on leaves and on fruits. You can see that cultivars such as Jonah Gold or Jazz are quite heavily susceptible to Venturia inequalis. So last example here, it's also apple scab and European canker assessment. So you can see also that cultivar like Briburn, Jonah Gold, or Kenzie are really quite susceptible to European canker and apple scab. Same thing on the right graphic with Jazz that show quite a high susceptibility to European canker. So those cultivar are not really adapted, were not selected for organic farming. So you already saw on the cours, the lesson of Clémence yesterday, the RIMPRO model that allow you to have an idea of the infection pressure here for Venturia inequalis, so for apple scab. And here is just the last year graph. It's just a representation of March, April, May, and June. And you can see the infection peaks, and you can also see in the bottom how many treatments were needed. And it's the example of one producer in Belgium, in Walloon region, how many treatments he had to do according to the recommendation of RIMPRO. So there was copper, sulfur, and BSC that were used. So it doesn't mean organic agriculture doesn't mean no treatment, and some people are confusing both in the general public. But still, because mostly of the cultivar that are not really adapted, it leads to the excessive use of fungicide spraying. So here it's an example also of apple scab on fruits. And here, for example, here the Jonah Gold cultivar had to be treated with 12 copper fungicide spraying and 19 fungicide spraying all together on one season. Due to that, in our chat, we have a philosophy that is the do not spray at all. And that's a strategy that allows us to, that we apply in the evaluation of chat. And it allows us to collect, as Mark said in the previous presentation, a lot of different strain, a lot of different race of apple scab, and to have co-evolution between the trees, the microbiome, and the different strains. So it also means then when we are evaluating a fruit tree, a cultivar, he will be submitted to a lot of different diseases. And it means to really understand what are the limits of the cultivar, what are the good traits and bad traits, and really understand the robustness of the cultivar and the resistance of the cultivar. So as I said, we have a really large diversity of apple scab strains, and most of the monogenic resistance are overcome in our orchards. So I'm going now to quickly define the breeding objective to create new cultivar, and we need to select for better adaptation to low input growing system, mostly organic, non-spray or low input breeding condition. And we need also to select for disease tolerance, robustness, and resilience. And also to broaden the genetic basis using local neglected fruit tree genetic resources, or some that are really original. We need also to select for good agronomic traits, so no biennial habits, good yield, easy training of the trees, and also late flowering, for example. And also specific quality traits like large spectrum of aroma, crispy flesh, and so on. And finally, better nutrition quality could be selected with vitamins, fibers, and other nutritional advantages. And for all that, we need a participative and organic and transborder approach. But of course, this is a long list of criteria, and you cannot select for all of them together in one shot, at least. So you need to prioritize a bit and to diversify the main objective. As with the climatic change, you don't really know what will happen. You need to explore different routes of breeding and have different routes of breeding strategies. So for the breeding, you need to select your potential parents. You need to know, of course, to know the ploidy level. Of course, there's a lot, at least in our collection, but I think it's a general thing. There's a lot of triploid cultivars that, of course, doesn't work for classical breeding strategy. And you need also to really characterize them. I think that with the previous talk, you already understand how important it is to really well know and characterize and assess your cultivars. But you also need to know their bad traits. So examples are pest and disease tolerance, the tree architecture, also the quality of the fruits, the yield, the maturity, the keeping ability, the flowering period, the phenology, and so on. So to sum up this slide, you need to properly locally evaluate your candidate parents in unspray condition during at least 5 to 7 years. And having this unspray condition really allow you to well know your cultivars and really know what are the traits and the behavior. So this is an example of high stem orchard where you can find, just to illustrate the fact that we were looking for rusticity, robustness in those old cultivar, and that we use this huge fruit tree genetic diversity in our breeding program. So as I said, you need to really know well your cultivars and to observe them long years. This is just an example of the pineal bearing habit. So you can see that it can really differ from the top to the bottom. So some cultivar have good fruits, but they have a huge tendency for pineal habit, which is no-go usually for the professional producer, but which could be an option for amateur garden. So you also need to know the average yield, and as it's depending of the one year to another, of course, you have to accumulate data for several years before to take a decision and to have a nice overview of the cultivar. So you already saw this graph on the Mark's presentation, but it just allow you to see that, for example, this Président Roulin cultivar have kind of robustness and tolerance here to against a scab. You see that depending of the pressure of the year, it always have a bit of scab, not really never, no scab. So it's not fully resistant, but it's still able to manage the pressure, and is always lower than the Golden Delicious in red in this graph. So this is just a final slide to sum up the selection process. So we have to go to the prospection to collect genetic diversity and safeguard it, and also the traditional knowledge around it. And then you have to characterize and evaluate those cultivars. And then you can have the direct use strategy that Mark just explained, and give a nice overview of all the strategy you can you play with to valorize directly the genetic resources. And then the last part that Mark were already talking about in this slides, where the last use, which is the pre-breeding and breeding process with these genetic resources. So while searching for a potential parent, you need to know the globally how are transmitted and inherited your important traits. And most of the traits will be polygenic. So it means that the resistance will be not linear, but more spread in the offspring with a Gauss curve. And it will be usually the mean of your parent. So while choosing your cross, you need, as I said, to balance your traits. So not to cross two parents with the same bad traits. And also you have to know that it's a bit more empirical, but some traits are better inherited than others. And there's also this epistasy phenomenon and interaction between genes that are not really linear, and that add another layer of complexity in the inheritance of the traits. So for the direction of the cross, meaning you choose the male parent and the female parent, in most cases, the early flowering parent is used as the pollen donor, as the male parent. And sometimes also due to some cytoplasmic inheritance, also the female parents have some higher chance to better transmit some traits. So you can have some reason to go on the other way around. Also, some parents are producing in general more seeds than other, and that can be taken into consideration while choosing the mother and the father for your cross. So this is just to illustrate a simple example of cross. So you have collected during several years on all your parents the maturity, the fruit-bearing habit, the keeping ability, the acidity, sugar, firmness, and so on, and also resistance to different biotic stress like scab, powdery mildew, canker, and also the general robustness of the tree. And you can start to see what are the good and bad traits of Van de Voet cultivar and of Ribinola, and what it could give if you start to make a cross between those two cultivars. So knowing that, I will
just a small remark. There is an inversion of the maturity. Ribinola is early September to mid-September.
Yeah.
And Van de Voet is mid-October. So there is an inversion.
It will be changed on the final version that you will receive.
Just a remark.
Good. So I'll go briefly through the principle of palm fruit breeding, which some of you probably already well know, but still, as I said, it's also in order to share how we are doing the breeding. So you probably know that there is male and female part on the same flower for, in this case, on the apple tree. So I will take the example of apple. So there is here, it's a bit cliche, the colors, but I guess everybody understands well which are the male and the female parts. So you will have first to collect, as I said, the pollen of your male. So we usually collect the flowers of the male parent at the balloon stage that you can see on top left. I don't know if you see my mouse or not.
Yes, yes, yes.
Yes, okay. So you can see here the flowers that were just collected at the balloon stage. Then you have to recover the anther. And we usually, after that, put them on a glass petri dish. You can see on left the fresh anther and then the dried anther that will crack open and release the pollen. So after that, you will have to store the pollen. And to store it, we use usually a desiccator, which is this a glass desiccator. And you can see that there is silica gel on the bottom of it, allowing to reduce the humidity and to store the pollen in good dryness condition on the fridge. So we store it at around +4 degrees. So as I said, you have to collect all the anthers. I can see the lady doing here this homework and starting to collect all the fresh anthers. And after that, as I said, you'll have to let them dry. We usually let them dry at room temperature, so around 20 degrees during 12 to 24 hours, depending of the temperature of the room. And then you have to store it in the desiccator as you just saw with silica gel. And then after that, what we do is the cold storage for several months. So if you want to early a bit and speed up the collection of the male the pollen, you can use this technique. Sometimes we cut branches, we bring them in a greenhouse, and this will warm up the branches. They of course put it in water, as you can see, and so the flower will mature faster and will be able to get pollen faster in order to be able to pollinate female cultivar, which is a bit flowering earlier in the season. So that's one of the techniques we used. So that's for the male part in blue. Then you, as I said, you collect the pollen, you let the anther dry, and they release the pollen. And then we usually use a glass stick, as you can see on this picture, to pollinate the flowers. And to pollinate the female, the flowers of the female parent. You have to prepare the flower, which is called emasculation. And here you can see some members of the team doing it. So you have basically to remove the petal, and to be able to put the pollen. So here's also a close-up. So I didn't say it yet, but we are storing. You probably saw that we are storing the pollen, the anther, in fact, dried anther in Eppendorf tube, which are small plastic tube. Here it's 2 ml tubes. And then we are waiting for the good day to make the pollination, which was really tricky to get this year. So it have to be, according to our experience, at least 15 degrees with, of course, no rain. And a good indicator is when the bees are flying, which means that the conditions are more or less met. So it's just a small video to illustrate the pollination. So you can see that the flowers were emasculated and prepared, and that with the stick full of pollen, we are pollinating here the flowers. Then you have to cross your finger and hope it works. Some people are also protecting the flowers with petroleum jelly, depending of the time you have. But usually the bees are not going anymore on the flowers when you remove the petal, and they are therefore more or less protected. Also, the flowers are saturated with pollen, which both avoid the cross-contamination with open pollination. So after that, you of course have to mark the branch you selected. We are not always making all the trees with the same cross. Sometimes if the tree is small or if there is low level of flowers, we pollinate the full tree. And sometimes we just mark the branch, as you can see here. So we usually prepare all the branches and then make the pollination. And after that, you have to collect the fruits, if they are fruits, and you have to mark the fruits and make sure they are not falling on the ground and that you cannot recover the good fruit. So one of the techniques is use potato bags like that, but it's quite time consuming and fastidious. So another technique we use, I had no picture, but it's just painting the fruits with a spray paint, and that allow you to recognize the fruit of a cultivar even if they are fallen from the trees. And of course, you can recognize the cultivar, so you can identify which cultivar is what, but I mean that the painting is also useful if you have trees that were on open pollination and not the result of your cross, that are, for example, on the top of the tree if you didn't did all the tree. After that, you have to collect, of course, the seeds and to dry them and also make the dormancy break. So the vernalization is done on the fridge on wet condition, and it takes around 70 to 90 days at the temperature of around 3 Celsius degree, 3 to 7. Depending of how our cold chamber is in shape. And of course, yeah, it has to be in a humid state. And also you have to avoid thermal shock after vernalization process. So once that is done, the vernalization process, we usually do it directly on Jiffy block. So that's those small block that once rehydrated looks more like that. And you cannot really see here, but it's all Jiffy blocks and they are covered with a bit of ground. But it means that you can separate all the small seedlings and evaluate them one by one. And it's easy to transplant. You don't break the roots, and the ground is well maintained. So we find it's quite a nice way. And we also add perlite on top. It's the white cover you can see here to avoid the fond des semis. I don't know in English how it's said, but good question. If someone know, it means that dying by an infection, yeah, killing of the small seedlings.
Damping off.
Damping off. Thank you, Mark. So after that, the small seedling are growing, and that's where we will start the first selection process. And for the first selection process, we do a scab tolerance assessment. For that, we have a spraying bench. So basically, you put your small seedling on the bench, and they will go through this equipment, and they will be sprayed. You can see here in yellow in the middle the sprayer, the sprinkler, and so it will uniformly put the same amount of spores everywhere on the small seedling. So you can see the movie, they are going in and they are sprayed on the same times. So we prepare a fresh solution of spores that we will use and that are harmonized and mixed to make sure that the solution contains the homogeneous concentration of spore during the spraying. And then once they are sprayed, they will be quickly transferred in humid incubator condition to allow the scab infection. Then we'll screen the small seedlings according to different class. So it's a simplified assessment scale for the seedlings, for scab. And we will keep the one that we are categorized in class 1, 2, and 3, sometimes the class 4, depending on how many seedling we have. And you can see at that mark that we are not looking for seedlings that are fully resistant, but that are more tolerant, that don't have a low level of scab infection, but still are showing some infection. The ones that are in the category 5 and 6 are discard. So we had, of course, to set up the experiment, and for that we tried different inoculum with, of course, the large diversity of strains of scab we have in the orchard. So we are collecting leaves a bit everywhere in the orchard and making sure that we have a good mix of different strain that represent the diversity we have here, and that we think it's a quite robust way to assess the general robustness of the seedlings. Of course, there is a concentration level. You don't have to be too high to be able to see and differentiate the ones that are quite tolerant, and you have not to be too low to be able to see something. So you have to find the good in between. This is an example of the transmission, a study of the transmission of this tolerance to scab. And you can see on the graph the different crosses that were made between Golden Delicious and several cultivars, and you can see how these cultivars will be able to transmit the scab tolerance. And you can see the categories 022 and in purple, and 023 in pink here. That's more or less the same, but it's more to assess the correlation between the evaluation of tolerance of young plant and then the adult one that were put in the evaluation orchard versus the young plant that were still in greenhouse. So as I said, each plant are classified and maintained in the different class of tolerance, the class 1, 2, 3, and sometimes 4. And they are maintained like that and put after that in the nursery, where evaluation will still continue during several years. This is just another example of another screening against neonicotria canker we are developing, which with an inoculation of young shoot, 1 year's young shoot. You can see that with the tips of the micropipette, we are putting a defined amount of spores. And then that with a caliper, digital caliper, we are measuring the evolution of the progression of the lesion on the bark. And that gives us, we are still developing so we are still acquiring the result. It's really fresh method and result, but we are still assessing if we can have a correlation between the tolerance of young trees and old trees, and if it's a reliable way to assess canker tolerance. So after this first evaluation step, we have the evaluation of the on breeding nursery, and they are put in natural selection pressure condition with no phytosanitary protection and very low inputs. So as I said, the plant will be, of course, evaluated for scab, for powdery mildew also, but also canker and architecture and several parameters. So this is also example of assessment on, I'm sorry, it's in the legend is still in French, but it will also be corrected. But it's also evaluation in purple here of apple scab and of powdery mildew in green. Also here it's another example of scab validation and test on evaluation orchards. And also just to show that the trees are followed during several years. And based on that assessment and all the parameters, the trees will be the elite cultivar, the most promising cultivar, will be grafted on most of the time M9 rootstock and still evaluated in the nursery for more parameters for the fruit quality, the pineal habits, and so on. And then you will know more about that tomorrow also. But the best cultivar will be evaluated in partnership with also other institutes. It will be participatory breeding with private growers, but I said also other institute in the north of France, the CRG, and with the same philosophy of low input farming system. So that's just a slide that recap a bit how many times it takes and the following of the different events. So as I said, the first seedling take, of course, it's a 1-year process. Then you have first evaluation of the young plant for scab, then scab and powdery mildew. Then the more promising elite cultivar are grafted. And you can see that we are evaluating more and more criteria. So scab, powdery mildew, canker, rosy aphid tolerance, the precocity, the productivity, the size and taste of the fruit, and also the shelf life, the storage in storage condition. And as I said, there is the participatory elite breeding, elite testing of the best cultivars. And to end up my presentation, just a glimpse and few 2 examples of what this kind of partnership and breeding program can give. You already hear about the breeding program for red-fleshed cultivars. So with the Stassen company, we had a breeding program aiming to have red-fleshed apple. And we finally managed to select a few cultivars that are promising. And also one that were selected by Stassen, which is called Halley's Double Red. And another cultivar that were selected through this process and breeding program is the Ducasse, which is a table apple, and which is a good example of cultivar selection. But you will learn more about Ducasse tomorrow on Mark's presentation. So I thank you for your attention, and we are, both Mark and me, open for questions.